video, we're going to take a look at an example of systems of nonlinear equations and how you would go about solving those algebraically. All right, now we're basically going to have three cases when we deal with, say, a linear equation and a parabola. So if our parabola happened to be an upright parabola and our linear equation crossed it as such, the points of intersection are the solutions to that system. Have two solutions. All right, a second case would be if we had either an upright or an up-down parabola and our linear equation goes exactly through the vertex. So if it went exactly through the vertex, we would have one and only one solution. All right, the third case scenario would be if we had maybe, say, an upright parabola and a linear equation that fell below it. It would not have any intersection points, so therefore that system would have a no solution. Okay, because the points of intersection when we graph them are our solutions. All right, so to work out one of these algebraically, let's say we had an x squared is equal to a 2y plus a 10, and then maybe say a 3x minus a y equals a 9. Now, of course, we could do this from a graphing standpoint, all right? However, we can also do this from an algebraic standpoint, and that's the approach that I want to take for this one. So what I'm going to do is I'm going to take one of these two equations, and I'm going to take the linear equation and solve that for y, because that's going to be the easiest approach. Then I can substitute that value back into that top equation. All right, so I'm going to solve, let's put linear equation for y. Okay, so that's going to be my step one. So I'm going to take that 3x minus y is equal to 9. I'm going to go ahead and subtract, or let's add y to both sides of the equation. So let's go 3x is equal to a 9 plus a y. Now let's go ahead and subtract 9 from both sides. 3x minus 9 is equal to y. All right, and that just makes it a really nice, easy solving there for y. And in that original equation, my y is not squared, so it's going to be an easy substitution back in. Okay, so then our second part here will be sub into our quadratic. So the x squared is equal to a 2y plus 10. All right, I'm going to substitute this back in for y. So I'll have an x squared is equal to 2, replace y with what it equals, 3x minus 9, and then the plus 10 on the end. So this is going to give us a quadratic equation. I'm going to do some simplifying on the right-hand side. X squared is equal to a 6x minus an 18 plus a 10. I can still do some more simplifying on the other side here. I can take a negative 18 plus 10 and get a negative 8. So I'll have an x squared is equal to a 6x and then minus an 8. Since it is a quadratic and I'm going to want that leading coefficient in front of my x squared term to remain positive, I'm going to move everything over to the left, set it equal to 0. So I'll have an x squared minus a 6x plus an 8, set that equal to 0. All right, now hopefully this is going to factor. All right, if it does not factor, we would have to use quadratic formula. But I really think our guess and check method on this is going to lead us to a conclusion here that it will factor. All right, if I do a 4 times 2, that's going to give me 8. That'll give me a 6 there in the middle if I make them both negative. So 4 times 2 is 8. I need a positive 8, so a negative times a negative will give me that positive 8. Negative 4x, negative 2x gives me the negative 6x in the middle. All right, then we can set each one of these equal to 0. So x is equal to 2 on this one. X is equal to 4 on this one. So I have got two solutions here. So this means this is case number 1. I have an upright parabola and a line, and that line goes somewhere through that parabola in a way that it will cross in two places. Now, we really do need the points at which they cross. So now I need to take each of these and plug them back in to find the y coordinate. Okay, so I'm going to plug them into the linear equation, because that's going to probably be the easiest. So let's put here, find solutions for our last step. I'm going to take the original linear equation. All right, actually it would be probably easier to plug in here. I'm going to take 3x minus 9 equals y, because we've already solved for y. I know what x is, so I'm going to plug x in 2 in. So 3 times 2 minus 9 equals a pair of 2, negative 3. So there's one of our solutions. All right, I'm going to do the exact same thing with the 4. I'm going to take this equation, just because it's already solved for y, it's going to be easier to plug in there. So 3 times 4 minus 9 is equal to y. This is going to be a 12 minus 9. That's going to give me a 3 there for the y. So that ordered pair then will be a 4, 3. So then my two solutions are going to be the 2, negative 3 point and the 4, 3 point. All right, so just one quick example there of showing a substitution method for solving a system of nonlinear equations, and specifically looking at when you are given a parabola and a linear equation. Definitely thanks for watching. If the videos are helping, please share with your friends so they can benefit too, and don't forget to subscribe to the channel. Thanks.